Now we are talking about the probability. Now it is one of the most important things if you are preparing yourself for a data science, right? So most of the machine learning models are based on probability, and it is a really important thing to learn in statistics. So it is a probability. What is a probability? Let's say it is a measure of a likelihood of an event, right? So it means that how much you can say that this event is going to happen, right? So if you say that tomorrow will be rain, right? Tomorrow it will rain, right? So how much chances that you say that it will rain tomorrow, right? So this is known as the simple probability, right? So we have a simple formula of the probability that the number of times an event occurs, right? Number of times an event occurs divided by total number of possible outcome, right? So this is the simple as the formula of the probability. So let's say I have this example of tossing a coin once, right? If I toss a coin, right? If I flip a coin uh, once, then I have these two possible outcomes. One, either I will get a head or I will get a tail, right? So if I say that what is the probability of getting a tail? If I flip a coin or toss a coin, then what is the probability of getting a tail, right? So it's quite easy to calculate it. So what do we have? Number of times an event occurs. So we say that we want a tail. So the tail is only one times, right? Divided by the total number of possible outcomes. So the total number of possible outcome is equal to the all of the elements that are present in your sample space. That is head and tail also. So there are two events that are in your sample space. So basically your probability is 0.5, or you can say in percentage it is 50%. Right, so it is quite simple. So probability of getting a tail when you toss a coin once, then it is a 50%. Let's take another example of rolling a dice once, right? So you know what is a dice? You probably you have played with the dice. This is like a cubical shape, and you know it has some sort of numbers written on it. Maybe there is a 4, there is a 5, and maybe there is 3 right there. So where there are total, 6 sides of a dice, right? So there is total 6 sides of a dice, and there are total the 6 outcomes here. So the total number of outcomes we have is 6. And what do we want? If we roll a dice once, then what is the probability of getting a 4? So 4 in our sample space, we have 4 occurring only once. So the total number of times an event is occurring is only 1. So our probability would be 1 by 6, right? So probability will be 1 by 6, right? So similarly, you can calculate it for the probability of getting 2. So 2 is also occurring once, so it will be 1 by 6, right? So this is how easy it is to calculate the probability. Now I wanted to talk about the important point in a probability is the addition rule of the probability, right? This is the important thing that you need to learn. So to understand it in a better way, I have just take this analogy or this example. So let's suppose I have this box, or you can consider it as a bag, right? So it is a bag, right? So I draw it in a square shape. You can consider it either a box or a bag, whatever. But here in this box, we have 5 blue balls. You can see there are 5 blue balls, 6 blue marbles, 3 white balls, and 4 white marbles, right? So I draw it with the color combinations. We have 5 blue balls, 6 blue marbles, and 3 white balls, and 4 white marbles here. Now, what does the addition rule of probability says, right? So if I talk about that, what is the probability of getting a blue ball? If I put my hand in this box, and if I try to pick an object, then what is the probability of getting a blue ball? What is the probability of getting a blue ball? So it is quite easy that probability. So I want to find out is the probability of getting a blue ball, right? So I'm writing here BB, which means blue ball. So how many total number of objects that we have in this space? So we have 5 into 6, that is 11, and 11 into 4, that 11 into 3, which means that this 14, and 4, 18. So total number of items that we have is the 18. So I write 18 in the denominator, and I want this blue ball. So how many blue balls are there? How many number of ways an event is occurring, right? Which means that how many blue balls are there? We need to find out the probability of the blue balls. right? So how many blue balls are there? There are 5. So simple, I have this probability of getting a blue ball is 5 over 18. Are you clear? Similarly, if I say that probability, find the probability of getting a white marble, right? So white marble. So what is the probability? So exactly we have 18, 18, we have 18 total outcomes. And how many white marbles are there? So there are 4. So it would be 4 divided by 18, right? So I hope you understand how to calculate this probability. One more thing I wanted to do here, what if I wanted to just say find out the probability of getting a white object. Now, I didn't define which object, either a ball or a marble, doesn't matter. I want a white object, right? So what would be the probability of getting a white object? It's simple, this right here, probability of this white object is like how many total objects are there? There are 18, right? So probability of getting a white object, how many white objects are there? There is 3 and 4. So we have 7 total total 7 white objects, right? So our probability would be the 7 divided by 18, right? So I hope you understand this, how to calculate the probability like this. So for the addition rule of the probability, what if I say that what is the probability of getting a, let's say, blue, which means a blue object, or balls, right? So we need to find out what is the probability of getting a blue or a balls, right? So which means that we need to first find out the probability. Let me just break you down the problem for you. Let's say I have this sample space here. The total number of the objects that are present in this space is 18. I have write this 18 here. And what it says is that I have to find out the probability of the blue object or a balls, right? So first I would need to find out the probability of the blue objects, right? So those objects which are blue. So how many objects are there? This is, 11 objects that are blue, right? So 11 objects are blue. So I wanted to find out the probability of the blue object. So how are you going to do this? First, you need to find out the probability. So how many, so it is quite easy. Probability of blue, that is around 11 divided by 18, right? So probability of the blue objects, 11 divided by 18 again. So first you need to find out what probability of, sorry. So you need to find out probability of B, right? Probability of the blue objects. Then what you need to do, you have to find out the probability of the balls. So the balls, so there are maybe white balls and also the blue balls. So I wanted to here discuss this thing that we have some blue objects and some white objects, right? So here are some white objects here, and total white objects we have is 4, 5, 6, 7. So there are 7 white objects here. Now we have 7 white objects, 11 blue objects. And I wanted to say that I want to know either a blue object or a ball. So I have this probability of B, and I have to find out the probability of getting a ball. So probability of getting a ball. So how much would be the probability of getting a ball? No matter either it is blue or a white. So probability of getting a ball, 5, 6, 7, 8. So there would be 8 divided by 18, right? So probability of getting a ball is P into, I'm reading it with probability of ball, right? So this is how you can calculate probability of B and probability of balls. And next, it says that it is the probability of blue or balls, right? So in this case, we have some white balls here and we have some blue balls here. So I need to find out that what is the probability that either it would be a blue object or a white ball, right? So I wanted to find out something that is between here, right? So this is this part, right? So I want to ask about this part. So how are you going to calculate this part? So this is basically an intersection of these two events, right? 11 blue objects and 7 white objects. This is the point where these common things are intersecting here in this point, in a way that probability of either a blue and probability of getting a ball, right? So this is your ball, right? So I want to ask is we have to just subtract it from the P. Okay, so we need to subtract it from this, right? We need to subtract, if you wanted to find out this thing, so we need to subtract this thing. So in short, if I write all of these things in a kind of a set theory or in a kind of union and intersection, then you can easily say, if I write it in a way of the union and intersection point, so it says that probability of blue, you can say probability of, so if you want to find out probability of blue or balls is equals to like finding the probability of the blue objects and then plus probability of balls and then minus probability of you know, P intersection, sorry, probability of blue intersection and balls, right? So this is how you can write it in a way like this. This is your intersection. Let me just clear this for you. This is an intersection, right? So this is the formula of the addition rule of your probability, right? Now I want to clear one more thing. There are some times where two objects are not dependent on each other, right? Let's say this is the event A and this is the event B, right? So this is event A and this is event B. Now these two are not intersecting each other. They are not indulging in each other. So these two are known as mutually exclusive. Now in this case, in a mutually exclusive case, right? In a mutually exclusive case, these two are not dependent on each other. They are independent. So in that case, this intersection, this will be automatically will be 0, right? So P, if you just say that P blue and balls and any kind of things, if I write it in a cleaner way here, so the probability of A and B will be equals to 0. A and B means intersection. Now in this case, there is no intersection between these two events. So automatically in this formula, this will be like 0 and you only have these two in your formula, right? So this is an easy way to understand these things. So this is your probability and the addition rule of the probability. I hope you understand this session. If you have any kind of questions that you can definitely ask me. Thank you.